How are you, listeners? I would like to welcome you to my mathematics video channel. My main focus is basically on revising grade 12 mathematics for those who will be writing metric. Our main focus today will be on quadratic number pattern. A quadratic number pattern is generally given by Tn is equal to an squared plus bn plus c. This is a general term. Now, when you want to find a general term for a specific number pattern, you must find your A, B, and C. Now, these are constants which can be positive or negative. But I think this is very important. Your A cannot be equal to 0, because once it is equal to 0, it means this term is not there anymore. Therefore, it becomes a linear number pattern. So for it to be quadratic, your A cannot be equal to 0. It can be negative, positive whole number, fraction, but not equal to 0. Now let us look at a simple example here. You are given 4, 7, 14, and 25. Now, if the question says, show that these 4 terms represent a quadratic number pattern, what's the approach? Basically, you are supposed to subtract consecutive terms 2 times, and then you must get a constant. Okay, let me just demonstrate here. If you subtract for the first time, what do we get? It will be 7 minus 4, which is 3. And then 14 minus 7, you'll get 7. 25 minus 14, you'll get what? 11. This is our first difference. Second difference, you subtract again. 7 minus 3, you get 4. 11 minus 7, you get 4 again. As you can see, these two numbers are equal. This is proof enough that it is a quadratic number pattern. So the condition is that if you subtract first time, second time, you must get the same answer. So therefore, we say it is quadratic. Why? A second difference is a constant. This is how you show that it is a quadratic number pattern. Now, this line here, 3, 7, 11, the first difference is, right? As you can see, the difference between consecutive terms is 4. If you want the next term, they will just add a 4. This line here is linear, because for you to get the next term, it is always having a difference of 4, 4, 4 throughout. Right, how do we find A, B, and C? If we apply the same process to this formula here, the way we did it with numbers here, you will realize that this position is going to be occupied by 2A. I think some of you have done the process before. And then this one here, it is going to be occupied by 3A plus B. And then a 1 substituted there will give us A plus B plus C. Now, to find your constants, that is A, B, and C, you solve these equations here, right? Starting with this one, because there is only one constant there, so it is easier to solve. So your 2A is equal to 4. You divide both sides by 2. What will it give you? A is equal to 2. So this is our first value. And then the next one, You substitute this one at that point. So it will give you 3a plus b is equal to 3. So it will be 3. We know a is equal to 2. So multiplied by 2 plus b is equal to 3. Then you solve this linear equation. It will give you b is equal to 3 minus 6. Because 3 by 2 there, it will give you 6. When you take it over, it will be negative what? Negative 6. So b is equal to negative 3. So that's the second value. Now, how many values do we know now? We know our a is equal to 2, b is equal to negative 3. We want to find c. We go up again. We use this equation, which is a plus b plus c is equal to 4. What is a? A is 2. What is b? B is negative 3 plus c. We don't know this value. This is what we want to calculate. So from that linear relationship again, we'll be able to find the value of c. What is c from there? C is equal to 4 plus 1. 2 minus 3, it will give you negative 1, but if you take it over, it will be plus 1. So c is equal to 5. Right, guys? I think at this stage, we've managed to find the values of a, b, and c. But please don't stop there. We want to find the general term, Tn, which is our nth term. So you then substitute these three values into that equation. Our a is 2, so it will be 2n squared, right? And then b is negative. So here it's a plus, but a positive and negative, it will give us negative 3n plus what? Plus 5. So the general expression for this sequence here, or quadratic number pattern, is 2n squared minus 3n plus 5. Right? When you are practicing on your own, you must always take these answers. You don't necessarily need a memo to do that. What you do is you check your terms here. For example, this one is occupying position number 1, 2, 3, 4. Position number 4. Supposing you don't know the number which is occupying position number 4, you then substitute a 4 here. Just to check. Alright, you say T4 is equal to 2 by 4 all squared minus 3 by 4 plus 5, which is equal to 4 squared 16, 32 minus 12 plus 5, which is equal to 25. So this general expression is giving us 25 after substituting a 4, which is our position. So it means term number 4 is equal to 25. For now, I would like to thank you for listening, guys. Just to a quick recap. Here, we were able to find the second difference, and then from the second difference, we used our 2a is equal to 4 to find a. We also used the 3a plus b is equal to 3 to find our b, and then we used this equation here to find the value of c. Please don't forget to substitute your a, b, and c to come up with the final expression. Thank you for watching. We'll meet again next time when we do other examples which are associated with quadratic number patterns. Thank you so much.